So in few couple of minutes, just I'll have an overview of some small topic like soil health in horticulture system, aberrations and adaptive concepts. And we all know like that probably we know what is soil health. Soil health. Any students among that? What is soil? It's a soil to function, is it not? It is a soil to function. Then we call it as a soil health. Very simple term to understand. But behind that, there is a lot of complications, lot of indicators required to assess, lot of properties are there to assess soil health. These are some of the properties where we can practice and integrate both all the three physical, chemical, and biological processes. And I've listed some of the particles, but these are some of the basic properties where we can have a component of soil health. And at the same time, now the operations are different. Like now we are talking either myth or reality. Still, we are unknown. We have been talking from several days soil health, soil health, soil health, and sustainability of production, sustainability productions. But it is unsure that where we have reached. But the practice, farming practice is continuing as such. You are not changing the practice. You are not oriented towards the soil health. This is where we are talking. And one thing, what to know about your soil, whether the soils are good for farming, and whether these soils are unlocking potentials, whether the potentiality of soil we have assessed, whether potentiality of the soil is related with the soil health. This is all some of the areas where we can concentrate. And most important, what I call some of the indicators what we identified is the aggregates. Aggregate size is most important. These aggregate size in the soils are very important to assess the one of the as a component of indicators, and the plays a significant role in rapid infiltration of the water and fairly rapid percolation of the water and retain sufficient water and well drained and well aerated. These are the components. One of the most important physical indicators, we take it as a aggregate particles. And most important is another one is compactness. The compactness, it depends on several factors, right? Spore space, bulk density, or particle density, or several other physical parameters. These all compactness depends on these parameters. However, that odd pans, whatever the breakage of odd pans is also indirectly related to the soil parameters, because the what you call the establishment of crop from the seeds to the crop or pedicel or to the crop, it is all depends on the soil. This thing and cover penetration and the root development. This is where you can say this is an odd pan, and highly compacted soil leads to a very low impact. This directly related to the water percolations, water infiltration and drainage, aerations, and restricted root growth. This is where in relation to the hardness, and most other important is soil crusting. Soil crusting is directly related to the seeding also. Either seed size, seeding, seed development, and pod and germination. This is all soil crusting. This is another third indicator, important indicator among the physical parameters. And with regard to the chemical, they are mixed with several components. The main component, what we are talking since the beginning and several decades, we are talking about the organic carbon, organic matters. That matters. Then that is as directly related with the microbial activity. And these two components plays a significant role, different mechanisms in the soils that I have shown here. Like there are several mechanisms, both this includes both physical, chemical, and biological nature. And these are some of the basic components of indicators what we take it as a soil health component. And now we come to the natural, what is going on at present. These are we call it as an aberrations. Because we have been practicing agriculture or culture or farming system continuously in different aspects. But we are not concerned about other aspects. Because see, in most of the vegetable crops, most of the horticulture crops, see, we have been cultivating vegetable crops continuously, crop by crop by crop over crop bar. So the cropping intensity is more than 100%. In such a situation, what happens? And application of fertilizers, most of the vegetable cultivating area, they are very high, high residual nitrogen, phosphorus, potassium. And there is a lot of imbalance in the soil. In such a cases, there is a lot of destructions in structure. So that's why what happened nowadays, like there is a crop, what you call a crop stagnation, what you call crop stagnations or crop attention. We call it as in the horticulture crop, where we'll restrict the cropping. Because we don't have, in that cropping system, we don't have a control over the farmers. But only in the research stations we have a control over the farmers. In such cases, what happens, the implication destruction of the soil structure. That is one area where we can have a continuous destructions and intensive tillage, intensive till, and that leads to the destruction, destroys the biological and ecological integrity of the crop and integrity of the soils. And this is one component where the tillage is going to, that's why even the present conditions have been natural farming, organic farming, so many, then regeneration farmings, all this have come out now. Recently, new terminologies have evolved. And this is one area. And other where intensive tillage plays a significant role in conserving several aspects, especially the soil organic levels. See, here the main activity is we always blame human actions. Of course, it is a human actions to extract more soil resources. So soil resources, mining, carbon and mining replenish great issues present day. And such cases like soil management techniques such as no-till system may result in lower carbon dioxide emission from and greater carbon sequestration in the soil. This is one area where really needs to be concentrated in the present ecosystem, carbon cultivations or nutrition management. And other aspects is uncertainty of the climate. So uncertainty of the climate also needs a main component area where soil health has to be has been brought under the management aspects. And several processes like hydration, chilluviation, ferrolysis, dilution of clay minerals, weathering or reverse weathering, all these uncertainty or climate change, this is what it happens. And this has been also not taken because of intensive cultivation and continuous cropping system and continuous tillage system. And another most important is among the climate patterns, soil temperature. Soil temperature has become really a vibrant soil. This led to the different degradation of the soil law, and especially the main carbon poles and nitrogens, and it has a drastic effect on the nitrogen cycles also. We have noticed that there is a direct relationship with the global carbon and nitrogen cycles with regard to this. And soil also, we know that it is an active terrestrial carbon pools. Almost it contains about 2,500 pegagram of carbon. Compared to about terrestrial biota, it's almost 620, and dietaries and 780 pegagram of carbon in the atmosphere. This is very reason. So soil is the big carbon stock pool. So this carbon stock, in order to maintain the soil, carbon stock has to be sustained for a longer period. However, the soil naturally sequesters carbon through soil plant system as a plant photosynthesis and then dead tissue to the soil system. This is a common practice which takes place most of the cropping pattern of farming. And other most important area what we have not considered is the water, because soil health and the soil water productivity, all soil availability, whatever, it is not independent. The both are interrelated. Unless we have a soil moisture, the soil health also may not be maintained. This is one area. And it has been estimated that soil poverty, water poverty is directly related to the soil, water specific depreciation. And soil health is also have a correlate with this water productivity. If you see the per capita availability of the water, is, as on today, is only 1,700 cubic meters per year. And you see the almost last 5 decades data, you see the requirement of irrigations, it's gone up to a maximum level. And however, the annual growth of irrigation is almost 0.5 to almost 2.2% is increasing. This is one of the important, and at the same time, what's happening? The food price index is also coming down over 5 decades. This is all because of our population growth. Probably the resources are there are limiting resources. The requirement is lower, and unless we concentrate both soil component as well as water component, probably will not achieve soil health. What is sustainability? This is where most important aspect. And other important is we are lacking. We all know that soil fertility, soil nutrient status are directly related to the human nutrition status. It is well established fact that, see, this is the widespread soil. You can just see the above this map, world map shows there's a widespread deficiency of the nutrients in the soil, whereas similar deficiency we have seen in human. This is very positively correlated worldwide by FAO. And today, I think it's already well established that almost 8 lakh people die every day due to zinc deficiency, and of which almost 4.5 lakh children are die under. They are poor in zinc deficient nutrition by this because of this malnutrition. It's become a global issue today. These are some of the aberrations what I noticed in the present scenario of agriculture. What has to be the concepts? We have drawn some of the concept in 2025 or 2030, probably that is the, we have sent to this thing. And one aspect, water productivity is a very important component. And we have tomorrow RAC meeting. The main discussion was water productivity in horticulture sector. In our institute tomorrow onwards, RAC meeting is starts. This is, see, if you achieve even 35% of water productivity, we will meet the requirement of 60 to 70, 80%. Requirement is sufficient. We can meet the demand. Only we have to achieve the product 35%, even 25 to 30%. If you achieve, that's good enough. Present day scenario. And most important, ecosystem service. And ecosystem service, I think Rajan knows. Now ICAR is encouraging ecosystem services. It is not independent of a crop. We not have a divide of the crop. We not monoculture. We are not encouraging monoculture now. Probably that's what natural farming, regenerative, all this by now present government. This is what ecosystem services and good agriculture practice. These are interrelated and has to be received. And this, we know the soil carbon sequestration is the ultimate one. Probably that where we component of different soil traits we can achieve in this soil sequestration. And most proactive steps presently required is regenerative crop nutrition system. Because see, we have seen almost 70 to 80% our what you call the nutrient density in our food has come down. It is an assessment from FAO. We have almost the USDA, United States Department of Agriculture, they've assessed from 1950 to 1999, the nutrient content of 43 fruits and vegetable crops found that 6 out of 13 nutrients studied, the decline 9 to 38% of nutrient density. This has led to the most of the third world countries malnutrition. And this is where I think concentrated, and they have impact. They have identified is the soil health, nutrient density, profitability in vegetable production, and biologically healthy condition 85 to 90% of the plant nutrition acquisition. That is meant bioavailability. What is acquisition? That's a bioavailability. So what we required is a better source for bioavailability. The produce what we get, the nutrient accumulation, the sources what we get, it is the component is declining. So the density of the nutrient may require to improve the bioavailability. This is where it concepts, and this is what I would like to give some of the topics. And finally, I would like to ensure that in order to have a better soil health, is the key to the soil health is soil water microbe plant continuum. This is where
being as a soil scientist, that we have mostly considered about the soil health and so on. That is ultimately it is aims to the getting the
produce
good crop and good crop. So even though now we are using that common practices like farmer practices that people are using so much of pesticides or whatever maybe chemical fertilizers and all. So even though that maybe nowadays is considered as some irrespective manner of application of fertilizers that can reduce the nutrient content of the economic products that we consume. So my question is whether we have to control that practice or we have to regulate the practice of that inorganic fertilizer, or else we have to shift over to the natural organic farming, natural organic farming. What will be the effective manner to increasing the bioavailability or biofortification of the economic products that we consume?
Your question is really out for the day. Because there are three things you should consider here: population, then population requirement, food requirement for this population, growth population, and nutrient density. All three are most important. So considering all three, we cannot neglect any of the source. Either we cannot neglect the inorganic source of fertilizers or organic sources or management. All three most important. In such a cases, in addition, what we require, our produce should have a more nutrient concentration availability in nature. So that's right now. Spot delivery nutrients has to be. It is evolved. Several other areas is already come up, but in agriculture still we are. I think that area definitely in future probably we may come up, because pharmaceuticals developed, electronically we have developed. The smart delivery system in terms of nutrient is most important. If you come up with that system, probably we may achieve all these three components, because produce should have a sufficient quantity of fortification with nutrient concentration. That is one area. And in turn, you should have a bioavailability when you consume it. These two aspects very important. Though crop is having high this thing, but is marketable produce is most important. This is very component. In West European countries, they are doing it so, but they have achieved. But what is the background, we don't know. That's what. So in Europe, because last time Holland, if you see in the market, all fresh vegetables, fresh things. This is what is happening. But they say it is a nutrient-rich vegetable. They say. I think some students should water productivity. A lot of funding also available. I suppose even our NRM and DDG also was talking. Horticulture also. Water product now work is in our work water productivity area. They are doing it.
If there are more interactive session with the external examiner, on behalf of the Tamil Nadu Agriculture University, Dean School of Postgraduate Studies and Directorate of Natural Resource Management, Department of Soil Science and Agriculture Chemistry, on behalf of all the faculty and student friends, we wholeheartedly thank you, Dr. G.C. Satisha, Principal Scientist. Definitely we have to thank you. Why? Because within a short spell of time, twice you came over here, that too evaluating a PhD thesis is not an easy job to be completed, but even after approaching you for delivering it, at concerned enough to give us yes, and immediately you are given your topic of the today's lecture and you enriched us. Always the short is sweet. So in a very nutshell, he has brought out how the soil, plant, microbe, and another extent animal continuum has to be there. As he rightly pointed out, soil health or soil quality, many times we just misnomer the fertility, quality, health, many times using of the terminologies. So even in classes, we used to interact what is fertility, what is health, and what is quality. As he rightly pointed out, as a whole now, the whole world, the scientific community look into the whole ecosystem. So soil is there, the soil, climate and other things, they play a major component. So that is the array. So we have to be in line with those things. So we thank you once again for delivering a very important lecture today. And I thank our Dean School of Postgraduate Studies for permitting us to conduct this guest lecture today with the external examiner. And thank the university for permitting Dr. G.C. Tatisha for having acted as an external examiner and speaker today. And I thank all the faculty members and the student friends and the PG coordinator of the department who has coordinated for this activity. Thank you one and all. Now I request the faculty and students to stay back for a few minutes. And I request chairperson, you please take care of external examiner. I'll join shortly with the